hope this is a very fast video, and that this clear we have previously I don't know why I'm not talking, but yeah, and previously we have talked about this too, right? And then we say that we're gonna talk about this in this video. And you may wonder, what is summation rule? Summation rule, I just want to explicitly define, I also forget, it's just the Einstein summation rule. It's just this one. Alright, how you would represent this whole lot of a component and a basis vectors in terms of a summation rule. So this using this method, you can actually redefine all of this long chunks of stuff in terms of this thing, and this is called the summation rule. Alright, I hope this is fairly clear, and I have explicitly defined this definition of summation rule. Alright, so therefore let's go into symmetry writing, symmetry stuffs. Alright, so what are they? I believe that you are already professional in symmetry, so I'll just briefly touch on it. Alright, so the matrix itself, T, alright, just previously we say it's W, but I just write it as T, has two initial notation, I and J, is equals to T, well in this case is J and I. Alright, so a symmetry can be represented in just these two terms. Alright, it can be represented in just these two terms. Alright, and therefore as you can see, T11, T22, T33, T12, T13. So T12 and T12 is over here. So symmetry, as you can see, this is the line. So if it's like a pancake, or like a cheese. So if you were to flip it up, they're actually the same. Alright, it's just the symmetry of the meaning of it. Alright. So if you were to look in terms of values, this can be fairly the case. Alright. If you were to look in this case, 3, 3, 4, 4 and 6, 6, they are like a mirror itself. Alright, but I just want to convey one important thing, is that if you were to write things in a more simple way in codings, alright, you're going to talk about the skyline. Alright, the skyline is simply this is a line above the sky of T11, alright, and then all this stuff. So this is the skyline of these things. I may be wrong, but this is the name of it. And the skyline itself contains these values, T11, T22, T33, and then all this value. So what I can represent this matrices, instead of this chunk of matrix, which I don't want, okay, I can simply rewrite this thing as T is equals to, alright, this is some I call it vector, I'll say, but anyway, so I can just write as T1 to T13. So this first three values are this diagonal values, and then I can just write out this T12, T13, and 323. Alright, mine. And then, sorry, I'll just add in with this skyline, okay? So it's T12, I think this will be better of an explanation. And then the skyline of T13. So I can represent these matrices in terms of like this, the symmetry. So this portion over here is this skyline, alright, in terms of T11 and this one. And then T12 and T23 is in terms of the skyline, and so on and so forth. Alright, I hope this is pretty clear for you. And when you write this in terms of transpose, so this will express your whole symmetry matrix into this one, and then it's easier to write in terms of coding. Alright, so now let's take a look in terms of the anti-symmetry. But before going there, I would like to give you the understanding that the strain tensor is symmetry. Okay, this is a concept understanding I just want to convey. Alright, so if I were to go to anti-symmetry now, alright, anti-symmetry, instead of Tij, alright, I'll just write as Uij is equals to, now it's minus Uji. Okay, I'm not not go into details of how this is being derived as an anti-symmetry, but I just want to convey that the important concept that the diagonal system are zeros. Okay, and then the mirror effect is just this one is positive, this one is negative. That's all. Alright, so how are this symmetry and anti-symmetry be useful? Is because when in terms of engineering coding, if you were to do software like SolidWorks or ANSYS and things like that, this representation in certain sense, I don't know how to represent this, but in a easier way to represent. So you can actually represent all these things easier in terms of a software. So it's more economy, alright, it's more economy for coding writings. Alright, and therefore this anti-symmetry is always most often, or alternatively you can call it as a skew symmetry. Alright, and therefore if you were to go into here, this is our summary page. Alright, we have cleared away the definitions of the vectors. Alright, in earlier videos we talk about the tenses. In previous videos we have explicitly defined all the stuffs and this one, and then in this video we talk about that. Alright, so in the next video we will talk about, next few videos we'll talk about operations of tenses and operator of tenses briefly. Alright, so it's briefly, I'll not talk into details because deriving it is really tough. Alright, and I'll also see you there, and bye bye bye.